So this is a wastewater sample. This wastewater sample is from a sewage treatment plant. The plant has not been efficient, and I wanted to demonstrate something because they have been trying to filter the water with a sand filter without coagulation or flocculation. So this thing I'm holding here is a solution that I've made from 40% ferric chloride. So it's the 40%, and I've made a solution. I have diluted further. So the thing I'm demonstrating is the efficiency of flocculation as opposed to filtering directly without flocculation. So this is a sewage treatment plant, and first of all I'm going to measure the pH and see the pH. So yeah, the purpose for coagulating is because the colloids that are present, which are the suspended matter, the only way to separate them from the water is through coagulation. As you can see, this is 6.54. This is 6.54, and yeah, so the best practice is to flocculate. So I'm going to measure I've measured the pH of the water. So with you'll see there will be a pH drop once I use this ferric chloride. It's a solution. I've made a solution. It's a dilute solution. So I just put a little, and then I will stir. Okay, please pardon me for the for the type of instrument that I'm using to stir, but anyway, you get the point. At this stage, there's no coagulation that is happening, and I'll tell you why. Because from 6.5 there has been a pH drop because of the addition of the ferric chloride. So it is not easy to do flocculation because it's just hydroxide ions that are present. As you can see, it's 4.7, 4.6, 4.61. It is dropping, and the pH is dropping. So it is impossible to achieve a flocculation using ferric chloride at that pH. So what I'll do, I have made a solution of sodium hydroxide. I've made a solution of sodium hydroxide, and I'm going to dose and increase the pH. Increase the pH to achieve a higher pH. And because of that, because ferric chloride is a stronger, what do you call this? It is a stronger, it has a stronger charge. It has a stronger positive charge. And when you add negative charge, which is a hydroxide ions, to the water, the hydroxide ions together with the negatively charged ions of the colloids, which are the suspended matter, they are attracted quickly by the already available charges of ferric chloride, which is ion 3. See, as you can see, I have achieved a pH of 10. I never showed it on the screen, but I've achieved a pH of 10. And now, as you can see, flocculation has started. The separation. Now the hydroxide ions and the negatively charged ions present in this water in the form of colloids has started bonding together with the ion 3, and this is what is happening. So the colloids together with the ion 3 are the ones that are coagulating, and as you can see, they are settling down. So it is easy to achieve filtration. It is very easy to achieve filtration using if you flocculate. As you can see, which a solution, a sample that was initially a wastewater sample with high levels of total suspended solids and turbidity. Now it is less turbid. Two, it has it is easy to remove the suspended solids because now they have separated from the water. All right. And the third thing is, once you solve the issue of suspended solids, trust me, the biochemical oxygen demand always automatically reduces. The demand of oxygen reduces because in this water, because the organic matter and the bacteria that are present have already settled down and can be easily separated and removed from the water, and you get a much clearer water sample. The chemical oxygen demand also tremendously changes as a result of separating, as a result of flocculation and coagulation. So the best way to separate is using the best way before filtration, in order not to overwhelm the filter, and the best way is to do flocculation. So for this time, for this part, I've used ferric chloride. There are alternative methods of flocculation. For others tend to use aluminium sulfate, which is called alum sulfate. And then after you filter, now you can chlorinate. It's easy to chlorinate. Okay, so this second part, I'm going to make a sand filter, and I'm going to use this jar because now after separating the suspended solids from the water, you need a sand filter or any form of filter. So this one is a makeshift sand filter. So I'm going to use this jar to act as my filter, so that I can filter this water sample and probably measure the turbidity. Yeah, so now I'm just using locally available materials. This is just a jar, or you can use a jar of your choice. So after I put the jar, I put a strainer at the bottom of the jar to prevent the sand from passing through the opening. So I've put a strainer. So that is a strainer, and that is the sand. All right. So after I've put the sand. So the sand is I've washed the sand in order to have, for it not to have the dust. So I've washed the sand thoroughly, and so the next thing we're going to do is that we're going to filter our sample that we had just flocculated. So as you can see, so this is just a makeshift sand filter. It's not like it's not something complicated or anything. So it does not matter even if there is